so yesterday I showed you those two equations, v equals u plus at, s equals u plus v over 2 times t. You can get more equations by doing a bit of algebra. If you take the first equation, rearrange it to make t the subject, t equals v minus u over a. Then if you substitute that into the second equation over here, you eliminate t. Do the algebra, square out the brackets, you get another equation. So if you do the algebra, you get this, then you get another equation, which is given to you. So this is an equation which does not involve t. So you can solve problems if you know u, v, a and s, that kind of stuff. Okay, so similarly again, you can eliminate v. There's more algebra. You can get another equation, s equals ut plus half at squared. So this is an equation that does not involve v. So if you don't know what v is, you can solve an equation using that. Similarly, with more algebra, you get this. So in the formula book, you're given these 5 SUVAT equations. Those are given to you. So they're called SUVAT equations. SUVAT. But it's best to just memorize them anyway. So if you do physics, you probably know them already anyway. First one, particle is moving in a straight line from A to B. Constant acceleration 5. A equals 5. The velocity of the particle at A, so this is the starting velocity, and it's moving in the direction A to B. Okay, so sounds like u equals 3, starting velocity. The velocity of the particle at B, so that's the final velocity. Find the distance, you want to find s. So you use the equation that does not have t. So the only equation you can use is v squared equals u squared plus 2as. Okay, so you plug in the numbers. V is 18, 3 squared plus 2 times a times by s. So then you just solve that equation to find s. So you can solve that equation. That will give you the distance from A to B. So s is the displacement from A to B. So s equals 31.5. You just solve it. Okay, next one. The particle is moving in a straight line. Constant deceleration. So deceleration means the acceleration is negative. So you will take A to B minus 1.4, slowing down. At time t equals 0, the particle passes through the point O with speed 13 meters per second. So this is the initial velocity. So when t equals 0, that will give you the initial velocity, 13. So in the book, they've done diagrams to help. Traveling towards the point A, you're told the distance OA is 20 meters. So that's the distance from O to A. Find the times when the particle passes through A. So you want to find the times. So you're interested in what t is. So you need an equation which involves SUAT. So it has to be, there's only one, s equals ut plus half at squared. Okay, so that'll give you an equation to find t. So you put in s is 20. 13 times t, so okay, this is where you need to be careful. A is negative a half, so you're going to have, okay, let's put it all together, half times by negative 4 times by t squared. So that's your, there's a t missing. So that'll give you some kind of quadratic equation. Okay, so if you simplify it, that'll give you 2t squared minus 13t plus 20. So that'll give you two possible values for t. So you can solve it by calculator or factorizing whatever way you want. But if you do it, you'll get two solutions, 2.5 and t equals 4. So they're both positive. That means they are both valid solutions. So to answer the question, so the particle passes through the point A after 2.5 seconds and 4 seconds. So the idea then, so if you look at the diagram, O, A, so originally it takes 2.5 seconds to reach the point A. And I guess it's going beyond A, then it just returns. So the particle is sort of going, continues forwards, then it goes backwards. So after 2.5 seconds, it reaches the point A, it continues on its journey, then it turns direction. So in total, after 4 seconds, it will pass through the point A again. It will continue its journey. So it passes through the point A at 2 stages after 2.5 seconds and 4 seconds. So 2.5 seconds is on the forward journey, 4 seconds is on the return journey. Then part B, find the validity when the particle returns to the origin. Okay, when the particle returns to the origin, S is equal to 0. So its displacement is 0. So in part B, returns back to its starting position, we know that the displacement is 0. It's back at its starting point. And all the other values are the same. So you've got U equals 13, A equals -4. Okay, and you want to find T. So you do the same equation, S equals UT plus half AT squared. So we use the same equation again. So this time we'll have 0 equals 13t minus 2t squared. So that will give you t bracket 13 minus 2t, 13 minus 2t. So that will give you t equals 0 and t equals 6.5. That gives you t equals 0 and 6.5. We get two answers. So t equals 0 is the starting position when it was at the origin. So to answer the question, the particle returns to the origin after 6.5 seconds. So the answer they want to the question would be 6.5 seconds. And it returns back to the starting position. So when you see that phrase, returns to the origin, back to the starting position, you take displacement equal to 0. Example 9. Okay, particle P is moving on the x-axis. So the particle is moving on a straight line. Constant deceleration, 2.5. So as soon as you see the word deceleration, it's a negative A, slowing down. Time t equals 0, the particle passes point P through the origin, moving in the positive direction of x. Okay, so all that says, the speed at the start is 15 meters per second. That's telling me that u equals 15. Initial velocity. Find the time, so you want to find t, between the instant when P passes through the origin and the instant when T returns to the origin. So this is the diagram may be helpful. So the particle is moving from point O. This is the x-axis to point A. You want to know the time it takes passing through O and the instant when, okay, so you want to know how long it takes to go forwards and backwards. So the path it's taken is like it's going forward and backwards. So it's going forwards and backwards. So you want to know how long it takes to travel forwards and backwards. So when it completes that path, the displacement is S equals 0. passes through the time when it passes through the origin and the instant when it returns back. That tells you need to consider s equals to 0. So the equation you can use to find t would have to be s equals ut plus half at squared. So s equals ut plus half t squared. So returns back to the origin means the displacement is 0. Okay, 15t half times a, so it's going to be plus half times minus 2.5 t squared. So that gives you a quadratic equation. So you get 0 equals 15t Okay, so solve that equation. Okay, so you get t equals 0, 15, and 12. So t equals 0 corresponds to the starting position. So it returns back to the origin after 12 seconds. So to answer the question, the particle takes 12 seconds to return back to base. So the answer to the question would be 12 seconds. Any questions on that one? Part A. Okay. Part B is easy. Find the total distance traveled during this time. So the distance traveled, think about it. So when it goes from O to A, so at this point here, okay, so the particle starts at O, its velocity is decreasing, because it's decelerating, and at some point the velocity will be equal to 0. So I'm going to work out the distance by finding the distance O to A. Then I'm going to times it by 2. Okay, so to work out the distance O to A, I know then that the starting value is u equals 15. Okay, when it reaches the point A, that's the point when it switches direction, b equals 0, and a is equal to, it's a constant, minus 2.5. Minus. Okay, so to find the distance, I need to use the formula with u, v, a, and s. So there's only one formula, v squared equals u squared plus 2as. Okay, so v is 0 at the point A. U squared is 15 squared. So that's 2 times minus 2.5 s. So I'm trying to find s. So that's the distance from O to A. So if you do the equation 15 squared divide by 5, I get 45. So that tells you s equals 45. Okay, that's the distance from O to A. But the question is saying find the total distance traveled during the time. So the distance traveled from t equals 0 to t equals 12 will be double that. So the answer to the question would be 90 meters. So total distance would be 2 times 45. Two times 45. There you go, 90 meters.